This is for 7.2, question 3. A random sample of birth weights of 186 babies has a mean of 3,103 grams with a standard deviation of 696 grams. These babies are born to mothers who did not use substance during the pregnancy. So question A is asking for what is the best point estimate of mean weight of babies born to mothers who did not use substance during the pregnancy. So to find the best point estimate in this case is your sample mean, which is your x bar, and it's given to us here is 3,103 grams. So that is your best point of estimate. Question B is asking us to construct a 95% confidence interval as in the mean birth of weight for all such babies. So in order for us to figure out this, you have to use the package called BSDA. So you have to type in library BSDA, and in order for us to use this library BSDA, you have to use the tsum.test. So tsum.test, you have to type in the mean.x, mean.x. Mean.x in this case is your sample mean. It's given to us by 3103. S.x, which is your sample standard deviation. In this case, is given us by 696. And n.x, which is your sample size, which is given to us by 186. Now the reason why that this question is using this BSDA package called tsum.test is because this question is given us the statistic, means the question provides us the mean, the standard deviation, and the sample size. For the previous example, the question called us to get the file name from chips. Okay, so that's why we were using t-test. So for this question, we will be using the 95% confidence interval. So your answer in this case will be 3002 to 3003. Now you notice that I did not type in the conf level here. So the reason why is because if you did not type in, your R will default it as 95%. So this is how you figure out here. There's written down here what percent is it. So in order for us to find the confidence 95% confidence interval for this question, it will be between 3002.3 to 3203.7 grams, and this is how we figure out this 95% confidence interval. Write a statement for part C. You have to interpret this confidence interval. So in order for us to interpret this, we have to write we are 95% confident that the interval between 3002.3 grams to 3203.7 grams, that's the interval that you just found early on, will capture the true value of the population mean. What we're talking about here is a population mean birth weight for all such baby. So that means you just need to copy here and you just need to paste it back in here. So this is how we interpret your confidence interval. And lastly, for question D, you have to compare the confidence interval from part C, those baby who birth weight for babies who mother who use substance, and the birth weight in this case is given us by the confidence interval of 2,608 grams to 2,792 grams. Then does the substance used appear to affect the birth of the baby? Why or why not? In this case, you find out that this confidence interval is actually way lower than those birth weight that babies born with a healthy mother. So in this case, the substance appeared to be affecting the birth weight. The answer definitely in this case is yes, because the confidence interval for mothers who use substance, the baby are born with lighter weight compared to healthy mothers. So so in this case, in other words, it's telling us that that means if you use substance, if a mother use substance, the baby actually is born less heavier, in this case not healthy, compared to those mother who are healthy in this case.